Hi all, in this video we're going to be going through a couple of the examples in the p-values section of the Module 3 lecture guide. So let's start off with example 1. It says, suppose we have the following hypotheses. We're assuming that 80% of all voters will vote for Mr. Young. That's our null hypothesis. That's what we're assuming. The alternative is that more than 80% of voters will vote for Mr. Young. So that's a greater than. So let's say we've done our statistics, we get a p-value of 0.021. So A says, write out a sentence that gives the interpretation of the p-value in context. In context means you got to connect back to the problem. So what we say here is, if we assume, and then we just blanket put in our null. So what I'm literally going to do here is I'm just going to copy this, paste it in. If we assume, copy, paste, 80% of voters will vote for Mr. Young, then the probability of getting our statistic or more extreme, again, this is another thing, this is what p-value means. So we're just going to say it every time. The probability of getting our statistic or more extreme is 2.1%. All I did was took my p-value, convert to a percent. Done. B, what is the contextual, again in context, conclusion we should make? Two options. It's the null is plausible, or we have evidence of the alternative. So what do? I take my 2.1% or my 0.21. I go back up to the way I define this in this little number line. 2.1% fits in here between 1 and 5%. Okay, that means I've got strong support for the alternative. So I scroll back down. We have strong evidence, and then instead of writing the alternative, I just copy and paste in here. Copy, paste. We have strong evidence that greater than, right here, greater than 80% of voters will vote for Mr. Young. That's it. There you go. So it's a lot of here are the pieces you have to say, put them down, throw in everything around it. All right, you don't have to start these fresh every time. You know what to say. Example 2. So the average length of all wires from a production line is 4.2 inches. The alternative is the average length is less than 4.2 inches, and our p-value is 0.28. So to do the p-value, we just, same thing. If we assume, copy and paste the null. Copy, paste. If we assume the average length of all wires is 4.2 inches, then now what's the p-value definition? Copy, paste it here. The probability of getting our statistic or more extreme is, and then take your p-value, throw it in, 28%. Well, 28% is pretty high, right? So 28% is way far away from 1%, 5%. So then in that case we say, we think the null is plausible. It is plausible the average length of all wires is 4.2 inches. We say, okay, seems reasonable. There you go. Okay, let's jump to number 5. These are very similar, so try these out, but the answers are here. So 5 says, suppose that our null is pi is 0.4, and our alternative is pi is less than 0.4. We've got a sample size n of 50, and we're going to do 100 repetitions in the simulation. We also have a statistic of 15 out of 50, or 30%. So what value is the distribution, aka the chance model, centered at? Don't look at it. Go back up here. Remind yourself. I built this chance model by assuming the null. What's the null? 0.4, you say? Well, then the middle should be 40% 0.4. Now, I have here number of successes clicked. So I don't want the proportion. I want to know what's on top here. Right? So what I have to do is I have to figure out, well, what's 40% of 50? Because that's what it should look like, and that's 20. And you can see 20 right in the middle here. So sometimes when you do this, you'll have a percent here or a percent here, right? And you'll be looking at this trying to use the percent, but it might say number. If you just click this proportion of successes button, everything will go to a decimal and it'll match how you wrote these things. That's what I always do, just to make sure I don't mess it up, because I'll mess it up otherwise. So again, B, if we switch to proportion of successes, we'd get 0.4 because again, that's our null. The null is the middle. The null is the middle. Find the p-value. Okay, the p-value is, take your statistic, put it on the picture. I see my statistic right here, so let's put in a little line for myself. So it looks like I see my statistic right here. So what am I going to do? I'm going to count all the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 dots here. And why am I going left? Because this told me go left. It's like the arrow's pointing me. Go left. So 15 dots at this line are to the left out of 100. There's my p-value. Okay. So what does it mean? It means if we assume that the true proportion is 40% for whatever this thing is, then the probability of getting what we got, our statistic, or more extreme, is 15%. And how do we know what to say with that? We'll go back to our little chart. 15% is too high, so I'm going to say it's plausible. Okay? So then how do we do this? All you got to do is type 0.3 into this box, flip this to less than, and hit count. And it'll grab that for you. So if you're not sure how to do that, go to the previous video. Maybe two more. One of the previous videos, and you'll see it. Okay, so let's jump down to 7. This one's very similar. Kind of showing you what things look like. So suppose that the null hypothesis is 0.25. The alternative is not equal to 0.25. I do 100 repetitions, and by the way, here's my statistic. So where should this chance model be centered? Don't look at it. You don't need to. Go right up here. It should be centered on what I told the computer to assume, 0.25. And look at that, it is. If we switch to number of successes, what would that look like? Well, it looks like I'm doing 200 of something here. That's my sample size. 25% of 200, what's that? It's 50. So if I click this button, a 50 will be in the middle. What's the p-value? Well, here's what we have to do. And this is a little tricky, okay, because we have the computer do it for us. It's not that obvious necessarily how we do this. But what do? We take our statistic, 0.2, we find it on here, and since we're doing not equal to, what we do is we go, okay, start at 0.2, count all the dots to the left, then go find me the statistic that's as extreme as that, but on the other side. And we see that that's 0.3. And we go count all the dots there and to the right. So 7 dots on the left, 6 dots as extreme on the right. Our total is 13 dots out of 100, or 0.13. Okay, so what does that mean? Write a sentence to give the value. So it says, this is the probability of getting a statistic of 0.2 or more extreme if the true proportion is 25%. What do we take with that? Well, our p-value was 0.13. Go back to our little number line. That's too big, so we say plausible. Okay, so let's do one more. Example 8. Suppose that we're assuming we have some average that's 315. Don't know what it is, it's just that's what our assumption is. We're interested in finding evidence, possibly, that the average actually should be bigger. We do 100 repetitions in the simulation, and we get a sample statistic of 319. That's our actual sample. So what do we do here? We go find 319 on here. We count all the boxes at 319 and bigger. Okay. So 1, 2, 3 boxes out of 100. So that's my p-value right here. Okay. So then where should this be centered? So let's not skip. Let's do A. Where should this be centered? Well, where did you tell the computer to assume? What did you tell the computer to assume? You said assume that mu is 315. Right in the middle. Okay, that works. Well, what is the p-value? Well, remember, the p-value is the probability of getting our statistic, 319, or more extreme, if really the true answer, the true mean, is mu is 315. So it's the chance we get this out of our sample if this is really true. All right? So what about our evidence? Well, 0.03, that's between 1% and 5%. Woohoo! That means strong evidence in support of the alternative. So that's strong evidence that the average, the true average, is greater than 315. There you go.